Question 25. When solving a system of linear equations, the following result is obtained: 5 equal to 5. This means the system has, those are the choices. So let's go ahead and review what does it mean by a system of linear equations. So normally we will have 3 possible answers. Okay, one is going to be just 2 independent lines, and then it crosses at one single point. So when it does that, we only end up with one solution. Now the other case is, okay, we can have 2 parallel lines, then that would mean they never cross. So that means we have no solution. Now the third case is when 2 lines overlap each other. So if I have 2 lines overlapping each other, then that would mean any point on the line are going to be the solution for the system. So this is a case where you will have infinite number of solutions. Now, how will I know which case is which? Okay, so let's look at the possible criteria. Okay, so for one solutions, you have 2 independent equations. Typical example would be like x plus y equal to 5, x minus 3 minus y equal to 3. Then we can solve it easily. That's not hard to solve. I can just go ahead and combine it. So I have 2x equal to 8, okay, and x equal to 4. Then when I plug it back in, 4 plus what gives me 5 is obviously 1. So my solution will be 4, 1. Now of course this graph doesn't really represent it, it's just like a quick comparison. This graph may not represent the equation here. Now, no solutions, how can I recognize it? By looking at the equations. So what I can have is like x plus y equal to 5 and x plus y equal to 3 as the 2 equations. I can solve it by subtracting. First, can we see that they're identical on the xy? The only thing different is the constant here. So what that means is the y-intercept that will be different, but the slope is the same. That's where it creates the parallel line. Now I can easily solve it by subtracting. So when I subtract, okay, I can change this to minus, that become minus, and that become minus. So when I add it, this will turn into 0 equal to 2, which is impossible to do. 0 can not equal to 2. It's not a true statement. That's a false statement. So when we create a false statement by using the calculation method, the conclusion would be no solutions. Now the typical example of the third case would be when they're identical, not just on the variable, but also on the constant term on the right hand side. Now because they both are the same equations, then it's obvious that they have to overlap each other's. Now if I perform the calculations, I will end up with, typical case would be, we will end up with this become minus, that become minus, that become minus. So we'll end up with 0 equal to 0, which is a true statement all the time. So that tells you that because the statement is true, no matter what order pair that satisfy one of them will satisfy the others. So that's how we get infinite number of solutions. Now the question is, Well, here it did not say 0, 0. It say 5 equal to 5. All they need to do is just change the format of the equations. So for example, let's go back to the equation 1. So let's call this equation 1. Let's call this equation 2. So I can just rewrite the format of equation 1 and 2. So for example, for equation 1, I'm going to just rewrite exactly the same. For equation 2, I'm going to move the negative 5 to the other side, the 5 to the other side become negative. So equation 2 I rewrite as x plus y minus 5 equal to 0. Now when I subtract the two equations, then I can see where the 5 equal to 5 come from. So when I subtract, we can see the sign change. This become positive. Now the x cancel, the y cancel, so we end up with 5 equal to 5. So to summarize this, if I perform an elimination method or substitution method, if I end up with an order pair like that, that would mean only one solutions. Now when I perform the elimination or substitution method, if I end up with just constant, there's no variable involved. So we look at the comparison of the constant. If it's a false statement, then we know that there's no solutions. So the third case is, when I use elimination or substitution method, x, y cancel out. I end up with two constant, but when you compare with two constant, whether the constant is 0, 0, 5, 5, 1, 1, 2, 2. If it's true all the time, that means we fall into this infinite number of solution. And in terms of the graph, that means you get the same line, they overlap each other. So any point on the line is going to be the solution for the system. So in this case, our answer would be C. So hopefully that gives you a quick recall of system of equation from the graphic method point of view and also from the elimination point of view, elimination method point of view. So this is question 25.